Hello friends, today I'm going to show you how can we recover a broken LVM mirror. As you know, LVM is a very popular storage technology, and there are various types of logical volumes that you can create in LVM, such as linear volumes, mirrored volume, striped volume, snapshot volume, and other RAID volumes can also be created in LVM, right? But today I am focusing only on mirrored logical volume, and we will see how can we recover from a from the failure of a physical volume that is used to create a mirrored volume. So let's first discuss what will be our topology. Here I am using VirtualBox, and in VirtualBox I have a machine which is RHEL 7M3. And if we go in storage, here I have four hard disks attached to this SATA controller. First one is RHL7 M3.VDI, which is the first hard disk on which operating system is installed. Then the next three hard disks, A21, A22, and A23, I have attached these other hard disks for different uh, lab purpose only, right? I'm going to remove these hard disks from here, and I will be attaching new hard disk, right? So I have removed 21, 22, and 23. The main hard disk, or the first hard disk, RHL7 M3.VDI, on which the operating system is installed. I'm not going to touch this hard disk, right? So for this practical, we need two hard disks initially, right? So I have selected the SATA controller here, right? Then I clicked on this icon to attach a new storage device. I selected add hard disk, then I selected create a new disk. Format is VDI, dynamically allocated. Let's name this hard disk A, B, or say B21. Then the size of this hard disk is say 8 GB. Then again selecting the SATA controller, I clicked on that attach storage icon again. Then I again selected add hard disk, create new disk, VDI, dynamically allocated. Let's name this B22. Again 8 GB of space. Okay. So what I have done here is I have attached two virtual disks to the SATA controller. Let's click OK, and let's power on this machine. Let's wait while the machine is booting. Okay, so the machine has booted now. Let's go and configure the mirrored volume. So if we issue the fdisk-l command, you can see that we have three hard disks. First one is dev SDA, which is 8 GB, and we have two partitions on it. First one is SDA, which is a boot partition. Second one is SDA2, which is a physical volume, which is used to create two logical volumes, one for the root file system, and second one is for the swap partition or swap logical volume, right? So we have attached two hard disks. First one is dev SDB, which is 8 GB. Second one is dev SDC, which is again 8 GB. So what I'm going to do here is first I will create um, a single partition of each of them, which is say of 500 MB. Let's go and do this. Let me brief you what we will do here. Say what we are going to do here is, on our system we have three hard disks. First one is SDA, second one is SDB, and third one is SDC, right? First hard disk, we are not going to touch this because on this hard disk we have our operating system installed. We are using the rest of the two disks for our test purpose. So what I will do here is I will create a partition on SDB which will be say of 500 MB, right? And this partition will become SDB1, right? Then similarly we will create a partition of 500 MB on second or third disk SDC which will be called SDC1, right? Then we will create physical volumes, and SDB1 and SDC1 will be uh, converted into physical volumes. Then we will create a volume group, say VG1, and these two physical volumes, SDB1 and SDC1, will be part of this volume group VG1. Then we will create a logical volume, say we will name it LV1, which will be say 500 MB, right? And this logical volume will be a mirrored logical volume. What it means is, if we create this logical volume as a mirrored volume, right, it will need at least two physical volumes, and we have two physical volumes here, SDB1 and SDC1. Each of them is of 500 MB, right? And when we create this logical volume of 500 MB or less, it will use both of these physical volumes, right? And the data we put here will be copied on both the physical volumes as it happens in mirrored volume, right? Then to test our recovery procedure, what will we do is we will remove this SDC hard disk from our system after shutting down the system. Then we will attach a new disk here, right? And then we will try to recover the data, right? So let's create the partitions first. So fdisk /dev/sdb, create a new partition which will be say primary partition, partition number 1, starting sector default, ending sector we will give here space, say plus 500 MB, then W to write and exit, right? Similarly, fdisk dev/sdc, we will create a new partition here, primary, partition number 1, starting sector default, size again 500 MB, W to write and exit. So if you see fdisk -l dev/sdb, spelling mistake, on dev/sdb hard disk we have a partition dev/sdb1 which is around 500 MB. Similarly, on dev/sdc we have a partition dev/sdc1 which is 500 MB in size, right? The partition type here is the default 83 Linux. You can change it to 80, which is Linux LVM, but that is not going to hamper its functionality. So we are going to leave it as it is. So let's create the physical volumes first. I'm assuming here that you have knowledge of LVM. You have basic knowledge of LVM, how to create physical volumes, volume groups, or logical volumes, and different types of logical volumes like linear, mirrored, striped, etc. If possible, I will try to upload those videos also So our focus today is only on this mirrored logical volumes recovery. So let's first create PV create dev sdb1 dev sdc1. So we created two physical volumes from these two partitions. Then vg create vg1 dev sdb1 dev sdc1. We created a volume group which is vg1, and vg1 consists of these two physical volumes sdb1 and sdc1. Then we are going to create a logical volume. So the command is lv create double dash type mirror. Number of mirrors will be 1. Size of the logical volume will be 500 MB. Okay, 500 MB, or let's say 400 MB. Then name of the logical volume is say LV1, and we are going to create this from volume group VG1. So the logical volume LV1 is also created. You can verify this. You can issue the PVS command to look for the physical volumes. So here we can see that under PV there is a physical volume SDB1 and SDC1, which are part of VG1 volume groups. Then these physical volumes are in size 496 MB, and we have 96 MB left in the first physical volume, 92 MB left in the second physical volume. Right, we will discuss it later. Then if we issue the VGS command, we can see the volume groups detail. Here we can see that we have a VG1 volume group which has two physical volumes, and we have created one logical volume from it. Its total size is 992 MB, and we have 188 MB free or in this volume group. Similarly, if we issue LVS command, we can see that we have created a logical volume which is named LV1. We have created this from VG1. It's a mirrored volume, right? Its size is 400 MB, right? So the logical volume we have created is 400 MB in size, and it's a mirrored logical volume. It requires at least two physical volumes of same size. So since we have configured while creating the logical volume that one physical volume will be used for data, and we will create one mirror. So there will be one physical volume for data and one for mirror, right? So the space allocation is, since its size is 400 MB, our first logical volume was 496 MB in size, right? And it has 96 MB free. So 400 MBs were allocated from this physical volume to our logical volume. Similarly, our second physical volume was 496 MB in size, and it has 92 MBs left. So 400 MB from this physical volume was also allocated for our logical volume. 400 MB from this, 400 MB from this, right? To create our logical volume. But as you can see, it has taken 404 MB and not 400 MB, right? So the remaining 4 MB is used for mirror log, right? But I'm not going to discuss those details here. I'm only interested in how to recover. So we have created a mirrored volume here, right? Let's format this. So mkfs dot say ext4 slash dev mapper vg1 lv1. We have formatted this logical volume, mirrored logical volume. Let's create a directory, say data 1000, or say data 500. Let's mount this slash dev mapper VG1 LV1 into this directory data 500. Okay, now if we see using df minus h, you can see that VG1 LV1 or the logical volume 1 is its size is 380 MB. Right, size can be different commands can differ on the actual size of the logical volume. So it's showing us that the logical volume is of 380 MB, of which 2.3 MB is used, 354 MB is free, and it is mounted on slash data 500. Let's put some data here. So I'm using the sequence command which generates numbers. So say sequence 1, 1, 2, 3, 4, 5, 6, sequence 10 lakhs, and I'm creating, if I'm generating this much of numbers 1, 2, 3, starting from 1 to 10 lakh, and I'm sending this data via redirection into data 500 directory in a file, say myfile1.txt, then the same data into a second file, say myfile2.txt. Right. If mm, if you want to see the data that is in these files, so let's read it. Let's slash data 500 myfile1.txt. So this file contains only numbers 1, 2, 3, 4, 5, 6, right, up to 10 lakh. So we created physical volumes, volume group, logical volume, a mirrored logical volume. We formatted it and mounted in a directory, and we put some data on our logical volume, right, using sequence command with redirection. Okay, so everything is working fine. Let's assume that for some reason our second disk crashes, right, and since we have created this mirrored logical volume using these two physical volumes, say the dev SDC hard disk crashes. If the dev SDC1 hard disk crashes, this physical volume will no longer be available, and our mirrored logical volume will stop functioning, and we will need to recover it. So how we will do that, right? So let's shut down the system. Shut down minus h now. I'm not going to crash that disk. What we will do here is we will remove that SDC hard disk from our system, right? And we will attach a new disk in its place. We are assuming this is our machine RHEL 7M3. In the storage settings, we had previously we added these two disks, right? So this third hard disk is SDC, and then we are assuming that this hard disk crashed, right? So we are going to remove this disk from this virtual machine, and we are going to add a new disk in its place, which will be used to recover our mirrored logical volume. Let's name this B23, 8 GB in size. Okay, let's power on this machine again. Okay, so we have removed the old disk SDC, and in its place we have attached a new disk, and we have rebooted the machine. So let's see what happened. We issue the previous command. We will see that there are some errors coming on. Is the device missing? And in the list of physical volumes, there is dev SDA2, dev SDB1, and in the dev SDC1's place, Now we can see here it's an unknown device, right? Similarly, if you see the issue the VGS command, it is also showing some error, and same is with LVS, some errors, right? If we try to mount slash dev, sorry, mount slash dev mapper vg1 dash lv1 to data 500 again, it won't mount, right? Dev mapper vg1 lv1 is not mounted. What we need to do here is we need to convert this mirrored volume into a linear volume. The data we put on this logical volume is still there on this working physical volume devsdb1, right? So if we convert this logical volume lv1 into a linear volume, we can mount this logical volume again, and we can list our data also, right? So first of all, what we will do here, we are going to show vg change minus ay double dash partial vg1, right? This will convert, this will minus ay is for to activate this volume group again, right? Then double dash partial is to convert our logical volume into linear volume. Then we will issue another command that is vg reduce double dash remove missing vg1. We are issuing this command vg reduce double dash remove missing vg1 to remove that unknown device. The physical volume that is not available anymore, dev sdc1, is removed from vg1 volume group. Now if we show pvs command, we have only one physical volume sdb1, there is no warnings, errors, and there is no unknown device in pvs commands output. If we show vgs command, it now shows that vg1 has only one physical volume in it, sdb1. And if you show lvs command, it shows that lv1 is a logical volume which is no longer mirrored. M is missing from here, which means that it is not a mirrored volume, it's a linear volume now, right? So if we mount, let's run our mount command again from the history. Mount dev mapper vg1 lv1 to data 500, it mounted successfully. And if we list our data ls data 500, we can see our files too. And if we want to read our files, then let's issue the less command, less data 500 my file 1.txt. We can read our data also, right? But this logical volume is not a mirrored volume right now, and we want to convert this to mirrored volume again. So how we will do this? So we have removed the SDC hard disk, and its place we have attached another disk. So the new disk is the new disk does not have any partitions on it. Def SDC again, right? If we print the partition table, there are no partitions on it. So we are going to create another partition, a new partition here, new primary partition number 1, starting sector, again the default one, and its size is 500 MB again. So we have created a new partition of 500 MB. Let's write it out. Let's create physical volume SDC1. It's a new physical volume. Let's add this physical volume to our existing volume group VG1, from which we created our mirrored logical volume earlier. So VG extend VG1 and extend by adding dev SDC1. VG1 extended. If we issue the VGS command, VG1 again has two physical volumes, but our logical volume is still a linear volume. Now we want to convert this linear volume in a mirrored volume again. So we show LV convert double dash type mirror, number of mirrors 1. We want to convert dev VG1 LV1, and to convert it into a mirrored volume, we will use these two physical volumes, dev SDB1 and dev SDC1. Dev SDB1 is already there. Now it will start using dev SDC1 also. It will take some time depending on the size of the logical volume. What it is doing here is it is copying data from dev SDB1 to dev SDC1. If there is data on SDB1, it will be mirrored to dev SDC1, and our logical volume will be converted to a mirrored logical volume. So it's done now. Now if we issue the LVS command, we can see that the M has came back here. So LV1 is a mirrored volume again, right? To confirm this, before that, let's read our data again, whether it is still accessible or not. So let's data 500 my file1.txt. So data is still readable or accessible. To confirm that it's a mirrored volume and it is using SDB1 and SDC1, let's issue LVS -a -so plus devices. Okay, so it is showing here that LV1 is our logical volume. It is created from VG1. It is a mirrored logical volume of 400 MB in size, right? It is 100% in sync, which means that the data has been copied on both the physical volumes, right? And it is showing here the images. LV1 mirror image 0, which is dev SDB1. LV1 mirror image 1, dev SDC1, and LV1 mirror log, right? So it is using 400 MB from SDB1, 400 MB from SDC1, and 4 MB is being used for mirror log, which is being taken from SDC1, right? So this is how we can recover a broken mirrored logical volume, and I hope this video was useful.